So hello and welcome everyone to our weekly session titled Latest in Bitcoin Tech, in which we go through the Bitcoin Optech newsletter to explore what's happening in the world of Bitcoin and what relevant news articles and new software updates and important documentation updates were worthy of being discussed in the past 7 days or 7 to 10 days. This week we'll be going through Bitcoin Optech newsletter number 290. Okay, so we have quite a lot of regular faces and also some new faces. So just to brief everyone, this is a weekly newsletter that basically covers news articles, then some changes to services and client software, some release and release candidates, some notable code and documentation changes that somebody who's enthusiastic about the technicalities of Bitcoin and wants to stay updated with the latest evolvements that are happening in the world of Bitcoin should go through. So we get together and we discuss this, and it's like a flat hierarchy. So anytime anybody has anything to share, any questions to ask, any anecdotes, any experiences, whether technical, non-technical, as long as they're relevant to the context that we're covering, please feel free to interrupt the speaker and share your thoughts. I'll start with the preface of this week's letter. This week's newsletter describes a proposal providing DNS-based human-readable Bitcoin payment instructions, summarizes a post with thoughts about mempool incentive compatibility, links to a thread discussing the design of Cashu and other ecash systems, briefly looks at continuing discussion about 64-bit arithmetic in Bitcoin scripts, including a specification for a previously proposed opcode, and gives an overview of an improved reproducible ASMap creation process. Also included are our regular sections describing updates to clients and services, news releases and release candidates, and notable changes to popular Bitcoin infrastructure software. The first news article, I'll go through the first news article, first go through the text, and then we can start discussing. First news article is DNS-based human-readable Bitcoin payment instructions. Following previous discussions, see newsletter number 278, Matt Corallo posted to Delving Bitcoin a draft BIP that will allow a string-like example @example.com to resolve your DNS address such as example.user._bitcoin-payment.example.com, which will return a DNSSEC signed TXT record containing a BIP21 URI such as Bitcoin. This is the address. No need to go through it. This is a Bitcoin address, mainnet address, like an example of an address. W1. BIP21 URIs can be extended to support multiple protocols. See the BIP70 payment protocol. For example, the following TXT record could initiate a Fetch32M address to use as a fallback by simple on-chain wallets, assigning payment address to use by on-chain wallets that support that protocol, and an LN offer to use by LN-enabled wallets. Okay, so this is an example, right, of an address that that will be returned by the DNS server when you query it with the string-like address. Okay, we'll go into the detail of this as much as we can. But yeah, for now, this is what the address will look like. This is what the DNS server will resolve the address into. The human readable address will be resolved into this format by the DNS. The specifics of the different supported payment protocols are not defined in the draft BIP. Corello has two other drafts, one a bolt and one a blip, for describing details relevant for ILM nodes. The bolt allows the domain owner to set a wildcard record such as *user._bitcoin-payment.example.com will resolve to a BIP21 URI containing the parameter of OM lookup, that is onion message lookup, and a blinded path to a particular LN node. A spender wanting to make an offer to example@example.com will then pass the receiver path, parentheses example, to that LN node to allow a multi-user node to correctly handle the payment. The blip describes an option for allowing any LN node to securely resolve payment instructions or any other node over the LN communication protocol. At the time of writing, most discussion about the proposed could be found on the PR to the BIPs repository. One suggestion was to use an HTTPS solution, which might be more accessible to many web developers, but would require additional dependencies. Corallo said he will not change this part of the specification, but he did write a small library with a demo website that does all the work for web developers. Another suggestion was to use the existing OpenAlias DNS-based payment address resolution system that is already supported by some Bitcoin software such as Electrum. A third significantly discussed topic was how addresses should be displayed. Example, these are the three formats that were discussed. So this article talks about a proposal for human readable Bitcoin payment instructions. Okay, this is something that a common procedure in a lot of other cryptocurrencies where you have human readable strings as your Bitcoin addresses, like how you have your Gmail address or your iCloud address. It's a human readable address. But even for that instance, the domain of a website could be bitshala.org. Okay. So in reality, it's just a human readable representation of uh, uh, I mean, like of a parameter or a different format that is stored in the DNS. All right. So what happens here, or what the proposal says, is that users will be allowed to get, this is like this. Okay, so this would be a Bitcoin address. Okay, so instead of having to share like a best 32M address or whatever, you can share an address of this format, okay, to receive payments over the Bitcoin network. And this human readable string will then be sent to a DNS server, okay, and the DNS server will resolve it to this, okay, this, and then the DNS server, okay, the DNS server will return this address after signing it for verification. Okay, so the information that is sent by DNS is signed using this mechanism referred to as DNSSEC to ensure that the information that is being sent has not been tampered while it's being sent. Okay, and so broadly, what this concept talks about is that you have a Bitcoin address, okay, a human readable Bitcoin address, because the contemporary Bitcoin addresses are human. They're not very convenient for humans to read, all right? It's almost impossible for you to type them without making any typos. You can only copy and paste them. It's very difficult for you to type them. So for convenience sake, this proposal says that Bitcoin addresses should be human understandable, just like email addresses are. Okay, like for instance, a human readable string, example at the example.com. Okay, then there must be a DNS server or a group of DNS servers. Okay, for instance, there is a DNS server that the relevant information for the example.com. There's a domain called example.com, and if your Bitcoin address is hosted on that domain name server will be queried with your Bitcoin address, and it will like reveal the actual address, okay, in this format, and then that address will be signed and return back to you for payment. Okay. Now, how this works is that one single human readable string will have three addresses. Okay. So, like this example at the rate example.com, when you query the DNS server, it will return you this thing. Okay. So there are three addresses in one. Okay. Like first is your Bitcoin address. Okay, it starts here, it ends here. Okay, this is the Bitcoin address. So if you intend to receive payment on the mainnet, you can use this address, for example, at that example. Okay, and you can accept payments on the mainnet. Then you have a fallback parameter. Let's say you want to accept a silent payment. Okay, then this will be your address, the second parameter, SP. Now let's say you want to receive a lightning payment. Okay, then this will be your lightning address till the end, for example. Okay, so with same address, you can accept Bitcoin payment or the mainnet, like a conventional Bitcoin payment. You can also accept a silent payment, okay, and you can also accept a lightning offer. So it's like 3 in 1. So what this proposes basically is that instead of like these complicated strings that we have today, which are prone to error and might not be compatible and convenient for everybody to use, there should be a mechanism for those who want to opt in to use human readable strings as addresses, okay? And those human readable addresses can encode multiple protocols together. The Bitcoin mainnet, for example, and the silent payment, for example, and the lightning offer, for example. So if you want to accept a payment on the mainnet, let's say you pass an argument, for instance, 0. Okay, now let's say 0 signifies the mainnet. Okay, so then this address will be executed. If you want a silent payment, maybe you pass an argument saying 1, which indicates that you want a silent payment. So this address will be triggered. And if you want to accept a lightning offer, then you maybe pass an argument 3. So this offer will be used. So this is, as per my understanding, this is the first of its kind where one single Bitcoin address lets you receive payments on 3 different protocols, on the Bitcoin mainnet, on silent payments, and also on lightning offers. Okay, this is broadly what this talks about. One thing that I'd like to introduce is offers, lightning offers. I don't know if anybody can, I mean, I personally, when I was going through this, I for the first time heard what a lightning offer is. Does anybody know what, like, any of you have heard what a lightning offer is? Cool. So, a lightning offer basically is a mechanism through which you can exchange Bitcoin in or Lightning invoices on the Lightning network. Okay. As per my knowledge, this is something that is not implemented currently on the Bitcoin network. Okay. So, if I want to send Bitcoins to someone, I will have to ask them for their address. Okay. That address, they can either send it to me via email or a message on WhatsApp or a message on Signal, or they can write it on a piece of paper and hand over that paper to me, or they can send from their wallet to my wallet. But this entire thing will happen off the Lightning network, right? Invoices cannot be exchanged on the Lightning network, and invoices can also not be exchanged on the Bitcoin network. All right, there's no mechanism for you to share your Bitcoin address through the Lightning through the Bitcoin network, right? You have to share the address, whether it's a Lightning invoice or whether it's the address. You have to share these things outside of the Bitcoin and Lightning network. What Lightning offer proposes is that Lightning invoices should be allowed to be shared on the Lightning network itself. Okay. So just like there are Lightning channels through which I can send sats to you and you can send sats to me using those same Lightning channels, we should also be able to share invoices. We should not be in need of using an external mechanism like an email or a chat application or a piece of paper or whatever. Right. Like just like we've discussed what out of band fees are, right? The first is like the implicit fee that we pay on the network, right? We've discussed this recently. When you're mining, when you want a transaction to get mined, you pay the miner by the difference of your input and your output. That is the implied fee. That is the fee that is paid on the Bitcoin network. All right. There is also this mechanism of out of band fee where you pay the miner outside the network. So currently, what we're doing is we're exchanging Bitcoin addresses and also Lightning invoices outside the Bitcoin address and the Lightning network, outside the Bitcoin network and the Lightning network, respectively. And an offer is basically a proposal that will allow you to share Lightning invoices inside the network. All right. So if you want to share Lightning addresses inside the network, you can share this human readable string. Okay. So these three protocols have been discussed here for human readable Bitcoin payment instructions. The first is mainnet that we're all aware of. The second is Lightning offer. I tried covering it to the best of my understanding. The third is another software protocol that I believe is on the mainnet also, which is silent payments. And we have Anmol here who's working on it as a developer. So Anmol, if you could just broadly take us through what silent payments are.
Yeah, sure. So silent payment basically is a new proposal for a new on-chain address format, which will like allow users to derive addresses without the use of XPub. So you share a lightning, so you share a like silent payment address once with everyone, and then anyone can pay you to that silent payment address, and they will use the silent payment address to derive a new address for every transaction, and then they'll like pay to that address. So this like eliminates the use of XPub where you need to like share an XPub and then the user derives new addresses based on XPubs. So this is like very good for privacy because every time you make a transaction, you get a new address because the address is actually calculated by using the inputs in the transaction.
Okay, got it. But using the master address, right? You share a quote unquote master address, okay, with everyone. Using
Yes,
that master address, a new child address, quote unquote, is derived for each transaction, right?
yes,
Okay.
but
So
like
can this
but
master, yeah,
there's yeah, but there's no linkage between like two addresses because like you can't like determine or like whether two addresses are linked to the same silent payment address or not. Whereas in case of XPub, like if I like share my XPub with everyone, so everyone can use my XPub to derive addresses and they can like know my wallet balance. But in silent payment, that's not the case. So like if multiple people use my silent payment address, they won't be able to uh, know about the other payments that I received from someone else.
okay, all right, got it. So even if somebody knows what your silent payment address is, they cannot there's no mechanism for them to determine which other quote unquote child addresses are linked or derived from this parent address.
Yes.
Great. Thanks a lot.
And like there's no like some other benefits are like it is there's no on-chain additional like anything on-chain that is additionally required for silent payment. So like basically the on-chain transaction will have a taproot address. So there are no sort forks required to activate this proposal. This is very good for privacy and like also improves user experience because now just have a silent payment address that you can like use to pay someone.
Right. And generally, that's a common concern among developers that whenever they come up with a protocol, they want to ensure that no drastic changes are needed in Bitcoin Core or LND or CLN. Like the protocol itself should not need drastic changes and it should be easily compatible with the existing version and the existing functionality of the current protocol, whether it's Bitcoin Core or LND or CLN.
Yeah, and it's very rare that you see a proposal that improves privacy but also improves like user experience.
Right. Great. Shyam, did you want to ask something?
Yes, I just had one follow-up question. And also, is it still that the sender derives addresses from the silent payment address, like with XPub, or how does that happen?
So the sender actually uses the input private keys in the transaction and then using like elliptic curve Diffie-Hellman, he like multiplies them with the public key from the silent payment address and then uses the tweaked public key as the taproot like public key to pay. And then the receiver can actually scan the blockchain and like yeah, in short, like that's what it is.
Right, it makes sense. Yeah, you were saying something?
Yeah, I was saying like I won't get into like too much detail because that would like I don't want to hijack the newsletter session to just talk about silent payment. But if you are curious to like learn more, I can like stick around after the call and then we can go over a detailed.
Right. I think it made sense on the high level, and I think is there any resource on Bitshala or any silent payment of you or someone else that I can go through?
Yeah, I'll drop it. I'll drop it in the chat.
Great. Thanks.
Right. One last thing that I'd like to cover over is this mention, right? This is like what do you call it? Like a filler kind of a thing. All right. So using this domain example.com, okay, you can use multiple prefixes, okay, like example 1, example 2, example 3, all right. So there's also a possibility that both allows a domain owner to set a wildcard record such as this, okay, and then you pass a parameter which is, for example over here. So input example over here, all right. So you don't necessarily have to stick to one address, all right. You have to stick to that domain. In that specific domain, you can have like a wild address or a wildcard record like this, and you can keep on adding prefixes to it. Okay, example 1, example 2, whatever you want to. So yeah, this is something that has been talked about a lot previously. It's not something that at least I'm hearing for the first time. But yeah, this is something special that one Bitcoin address allows you to receive regular conventional payments, also allows you to receive silent payments, also allows you to receive lightning offers. This is something that I'm hearing for the first time. So this was something noteworthy in this proposal made by Matt Corell. Also, the DNS sec, okay, generally the information that is retrieved from the DNS server, it is not authenticated, but here this additional mechanism has been added of DNS sec to ensure that the information that is being retrieved by the DNS server is authentic. Cool. So this was the first article. Okay. The second one is it's like a summary of a huge you can follow research by Sohas okay, and his articles like are very well articulated and like very well very detailed generally. Okay, we need a lot of time to cover them, so we won't be able to cover it throughout because it's outside the purview of the session. But we just go through it and discuss a couple of nice points if we can. Cool. So the second one is thinking about mempool incentive compatibility. So as Gaffer posted to Delving Bitcoin several insights into the criteria full nodes can use to select which transactions to accept into their mempools, relate to other nodes, and mine for maximal revenue. The post starts from first principles and proceeds to the cutting edge of current research with approachable descriptions that should be accessible to anyone interested in the design of Bitcoin Core's transaction relay policy. Some of the insights we found most interesting included pure replace by fee rate doesn't guarantee incentive compatibility. It seems like replacing a transaction paying a lower fee rate with a transaction paying a higher fee rate ought to be strict when for minors. Software provides a simple illustrated example of why that's not always the case. The previous discussion of pure replace by fee rate, see newsletter number 28. Miners with different hash rates have different priorities. A miner with 1% of total network hash rate who forgoes including a particular transaction in their block templates and manages to find the next block will only have a 1% chance of mining an immediate successor block that could include that transaction. This strongly encourages the small miner to collect as much fee as it can now, even if that means it significantly reduces the amount of fee available to miners of future blocks, including itself potentially. By comparison, a miner with 25% of total network hash rate who forgoes including a transaction in the next block will have a 25% chance of mining an immediate successor block that would include that transaction. This large miner is incentivized to avoid collecting some fees. Now, if doing so is likely to significantly increase the available fees in the future. Kafka gives an example of two conflicting transactions. The smaller transaction pays a higher fee rate, the larger transaction pays more absolute fees. If there aren't many transactions in the mempool near the fee rate of the larger transaction, a block containing it would pay its miner more fees than a block containing the smaller, that is the higher fee rate transaction. However, if there are many transactions in the mempool with similar fee rates to the large transaction, a miner with a small share of total network hash rate might be motivated to mine the smaller, that is higher fee rate version to get as much fee now. But a miner with a larger share of total hash rate might be motivated to wait until it's profitable to mine the larger, that is the lower fee rate version, or until the spender becomes even more tired of waiting and creates an even higher fee rate. The differing incentives of different miners may imply there is no universal policy for incentive compatibility. Finding incentive compatible behaviors that can't resist DOS attacks would be useful. Daftar describes how Bitcoin Core project tries to implement policy rules that are both incentive compatible and resistant to denial of service attacks. However, he notes an interesting and valuable area of research would be to determine if there are incentive compatible behaviors that would not be DOS resistant to deploy on the entire network and characterize them if they exist. If so, such behaviors could introduce an incentive for users to connect directly to miners, which might be mutually beneficial to those parties but harmful to the decentralization of mining on the network overall. Understanding those scenarios may also be helpful to us as we try to design incentive compatible protocols that are loss resistant so that we know where the boundaries are of what is possible. So, this post basically talks about it basically asks question about whether is there a deterministic algorithm that assures at every given point in time in every given scenario the miner can use that deterministic algorithm to ensure that he is maximizing the potential fee available for him, right? And the answer is that this problem till date is unsolved. Okay, there is no deterministic algorithm that you can feed into your ASIC machine, into your mining machine that will ensure that at any and every given point in time, it is like every transaction that enters your mempool will always ensure that your fee goes up. All right. So if your mempool, let's say, is full, and there's a transaction coming in, okay, and that transaction gets into the mempool and knocks out an existing transaction, okay, there is no mechanism that ensures that the incoming transaction will always increase your fee as compared to your previous set, which had the outgoing transaction. Okay, so currently the mining algorithm or the inclusion algorithm in the mempool is such that the transactions are included based on the highest ancestor fee. So if a transaction is trying to enter the mempool and the mempool, let's say, it's full, then it will be its ancestor fee will be calculated. It will be seen whether it has any unconfirmed transactions in the mempool. If yes, then it will be seen what fee do all those ancestors, what fee rate and what absolute fee do all those ancestors pay cumulatively. And then it will be calculated whether including this transaction will have a higher fee rate as compared to a transaction that it will potentially drop out, right? Now, this might ensure that the transaction that is coming in pays a higher fee than the transaction that is going out, but it does not always assure that the entire block that will get mined after this transaction entering the mempool will be higher than in the previous scenario. All right. He gives some examples. We just go briefly to the post. Okay, and he eventually concludes that currently there is no such mechanism, deterministic algorithm, that always ensures that an incoming transaction will 100% always increase the minus fee. Okay. For example, I think this would be a nice example of that. Yeah. Okay. So he gives the example of there's a transaction A that is already in the mempool. Okay, it's paying 1 sat per virtual byte. Okay, there's another transaction that's also already in the mempool. That's transaction B that's paying 10 sats per virtual bytes. Okay, transaction B is the child of transaction A. Okay, now transaction C is trying to enter the mempool. Transaction C is trying to enter the mempool. So TXA is low fee rate. As we can see, TXA is 1 sats per virtual byte. It's a low fee rate, and TXC has a higher fee rate than A. Okay, this is TXC. It has a higher fee rate than A. But A plus B together have a higher fee rate than C. Okay. So A has 1 sats per virtual byte. Its child B has 10 sats per virtual byte. So these two transactions, A and B, cumulatively 8.5 sats per virtual byte. Okay. Now there's a new transaction that wants to enter the mempool, transaction C, that is paying 3 sats per virtual byte. Okay. So transaction C is paying a higher fee than transaction A. Okay. But it's paying a lower fee. Okay. Lower fee rate as compared to this combination of A and B. Okay? Of course, the intuitive answer here is what we probably want is that we probably want to bundle A plus B together and select them as a single chunk of transactions before C. How can we systemize this understanding and reconcile it with the idea that transaction C has higher fee rate than transaction A, and therefore in some scenarios ought to be selected first? Okay. Now, currently the mempool. Okay. Now, what's important to understand is that this transaction C is competing with transaction A. Okay, it knocks out transaction A. Like these transaction A and transaction C are two conflicting transactions. They're both trying to spend the same input. So either A can stay in the mempool or C can stay in the mempool. Both cannot stay in the mempool because they're both competing with each other. They're spending the same outputs. Okay, so now the miner has to decide whether to let A in, whether to allow A in, or whether to knock out A and allow C in. Okay? Now the current mempool algorithm, what it will do is that it will allow C in. Okay, because the fee that C is paying is higher than A, right? And while inclusion, you take ancestor fee into consideration. So A has no ancestors. Okay, the descendant is not taken into consideration while including a transaction in the mempool. Its ancestors taken into consideration. So A has no ancestors, no unconfirmed ancestors in the mempool. C has no unconfirmed ancestors in the mempool. Okay, so now A versus C. C is paying 3 sats per virtual byte. So the mining algorithm in Bitcoin 2 will include A inside the mempool and will include C inside the mempool and kick out A. Now, what it is doing is by kicking out A, it obviously kicks out B too, because B depends on A, right? And if there's no A in the mempool, there's no B in the mempool as well. Okay. So ideally, it should have stuck to A plus B, because A plus B is 5.5 sats per virtual byte and C is 3 sats per virtual byte. Okay. So allowing A to continue being in the mempool along with its child would have been beneficial for the miner, but current Bitcoin core mempool algorithm will kick out A and B both, because it will compare A with C. Okay, and that is why it is said that the algorithm that is used to decide which transactions are to be included inside the mempool or kicked out outside the mempool is irregular. It's consistent. It's inconsistent. Okay, the algorithm is doing the right thing by allowing C, okay, but the algorithm does not take into consideration that A has a child B that is paying 10 sat per virtual byte. So in an attempt to try to maximize the miner's fee, what the algorithm in Bitcoin Gold currently will do is deprive the miner of 2.5 sats per virtual byte by kicking out this parent-child chunk of 5.5 sat per virtual byte and including the C. So that is what the problem is. Okay. So if we analyze, for example, this fee rate diagram at every stage, okay. For instance, let's say that we have to include only this is the blue graph is ABC and the red graph is C. This is C, A, and B. Okay. So if only one transaction has to be included. Okay, let's say there are 3 transactions and we are only allowed to take one transaction out of these 3 transactions. Okay, if we allow that one transaction to be A, we're in loss. And if we allow that one transaction to be C, we're in profit. Okay, now let's say we can only select 2 transactions. Okay, if we allow those 2 transactions to be C and A, okay, C and A, again we're in loss. But if we allow those 2 transactions to be A and B, we're in profit. Okay, now let's say we are allowed to include 3 transactions. Okay, now those 3 transactions are A, B, and C, or they could be C, A, and B. Okay, so we make the same profit. Okay, so using the same mechanism, right? Using the same mechanism, if we let's say if we use an algorithm that allows us to take descendant fee into consideration, we will use A and B, and at that time A and B will be more profitable. Okay, and if we're allowed to keep only one transaction at a time, okay, then in that case C will be more beneficial. Okay, and if we can keep all 3 transactions in the mempool, then in that case it doesn't matter whether you take A, B first or you take C first, we're equally profitable. So there is no deterministic algorithm that can tell you that hey, 100% including C is beneficial, or hey, 100% including A and B is beneficial. All right. If you want to include only one transaction, then taking C is beneficial. If you want to include 2 transactions, then taking A and B is beneficial. If you want to include all 3 transactions, then it doesn't matter whether you take A, B, and C, or whether you take C, A, and B. It's all one and the same. All right. So the question that Suhas asks is there an algorithm that can always ensure that if we want to take one transaction, it'll be the best transaction. If you want to take 2 transactions, they'll be the best transactions. If you want to take 3 transactions, they'll be the best transactions. The answer is no. If you want to take one transaction, then the red path is better. Okay. If you want to take 2 transactions, then the blue path is better. If you want to take 3 transactions, then both the paths are equal. So there is no one path, all right. There's no one path that can deterministically tell you that hey, follow this path and you'll always be profitable. Go through the blue path and you'll always be profitable, or go through the red path and you'll always be profitable. So this is like a cash 29 situation for miners. Okay, so he basically compares different situations. Yeah.
Hi Faisal,
Yeah.
sorry to interrupt you, but I had a confusion that why will we have 3 transactions? Because aren't A, B versus C conflicting transactions pending the same inputs?
Yeah, they are, but it's like what if you had space to include all 3 of them? Okay, like this is like a general example, right? Here the situation is that it is trying to kick out A is trying to kick out C. Okay, just let me go through it. That's a very nice question. Are they conflicting, or maybe it is something that I read somewhere and put it over? I don't think they are conflicting. Oh, they're not
Right, I
conflicting.
think it's
Thanks for
likely
bringing
that
up
they are
that
not
point.
right. They are only competing
Yeah.
for fee. They are not competing for the same output.
Right, they're competing for block space. Right. We'll come across conflicting examples further. We might not be able to go into the details of them because one example took us so much of time. Okay, so yeah, they're competing for block space. Okay, yeah. So basically, there's no one path. Okay, that you can follow. He gives us various other examples, like he draws a convex hull. We take a lot of time to go through what a convex hull is. Can we use the convex hull? And then he concludes that no, we can't even use a convex hull. Come to a deterministic algorithm. Can use clusters, and then his response is no, we can't even use clusters for that. And then here he uses an example of a conflicting transaction, B and B dash. Okay, and then in this example, A and B are in the mempool, and B dash is the potential replacement of B. Okay, so here the transactions are conflicting. B dash is conflicting with B because they're both trying to spend the same transaction. That's how it is worded. B dash pays a higher fee rate than B, yet a miner including A plus B dash collects a low fee rate and lower total fee than a miner taking A plus B. This should make it clear that merely requiring the fee rate of replacement to be higher, even much higher than its conflicting transaction, is insufficient by itself to guarantee incentive compatibility. So here B dash is paying a higher fee rate. It's paying 10 sats per virtual byte, and here B is paying 5 sats per virtual byte. Okay, so these two are conflicting transactions. Okay, however, A plus B, the cumulative A plus B chunk will give you a greater absolute fee and a greater fee rate as well as compared to B dash. But the current algorithm will kick out B and retain will kick out B and retain B dash, whereas what is more profitable for the miner is A plus B. Okay, because this is 20 kilo virtual bytes and this is 100 virtual bytes. This is another situation where the current Bitcoin core algorithm chooses a transaction which is less profitable for the miner. So he's just giving examples of how the current Bitcoin core algorithm for including transactions in the mempool is deficient, and he says that it's a problem that is currently not solvable. various other examples he gives next month. So whoever has time should go through multiple examples, right? These are very, very illustrative.
It's the same article you shared on the general channel, right?
Yes, exactly. And it's a wonderful article. A wonderful article.
Right.
I definitely recommend everybody to go through it. Here he uses an example of cluster. Like there's an A transaction, okay, and there's a B transaction, there's a C transaction. There's an absolutely independent D transaction, but it is conflicting with C transaction, C dash transaction. Okay, so C and C dash are trying to spend the same input. Okay. Now these are two conflicting transactions. Now this is paying a higher fee. All right. So the mempool will include this because if these two are conflicting, it will include this. All right. But ideally, including this entire chunk is more beneficial for the miner. And he gives examples, he gives a lot of math. This is a wonderful article for whoever, like I said, has 1 hour of free time to go through it. Okay. And then he also gives another example about how, for instance, there is a transaction that is trying to enter the mempool, okay, and the mempool is full, okay. So now the miner has to decide whether to let this transaction inside the mempool and kick out an existing transaction, or let this transaction wait till a block is mined and there's more space in the mempool and then allow it to include. He says even that will differ from miner to miner. Okay, it also differs based on your hash rate. If a miner has a very low hash rate, then it will be profitable for him to include a transaction and not wait for the next block. And if a miner has a very high hash rate, then it is profitable for him to kick that transaction out for now and include it in a future block, because his chances of mining the future block is higher as he has a higher hash rate. He does some math, all right? So what if the miner who has 0.5% of hash rate waits? Okay, what will happen? And what if he becomes greedy and he includes a transaction right now in the block? Okay, so he says that it is better for a miner. Sorry, it is better for a miner with a very low hash rate to wait. Waiting policy is better for him. And if the miner has a very high hash rate, in that situation, greedy policy is better for him. If he has 25% of the hash rate of the network, then greedy policy is better for him. And then wait policy, sorry, is better for him. You see, 25,000 is the score and 6250 is for greedy. And if he has very low mining power of 5%, then it is better for him to be greedy and include that transaction in the block right now and not wait for it. Okay. So yeah, like.
So I think as a thumble, it's very dynamic, right? Depends on hash rate, depends on right.
A lot of
it depends on every mempool for themselves. There's no general right.
So it depends on the ancestor fee rate, then it depends on the descendant fee rate, it depends on the hash rate, it depends on a lot of factors. So it's not possible for someone to come up with a software and tell them, hey, you just run this software on your ASIC. This software ensures that at every given point, you always 100% including the best transactions in the mempool. It is not possible, at least for now, to find such an algorithm. The current algorithms, the way they work, it is highly possible that your mining node will kick out a transaction that is more beneficial for you. So yeah, that is the gist of it, and it's a wonderful article for whoever wants to read it.
Right, it's an interesting problem, right? I think as Bitcoin becomes more stable in its adoption and hash rate and I think fee rate also, I don't know if fee rate can ever be one stable metric, but I think there will be some data analytics in future which can tell some miner how to optimize for fee. I think it's already there, but it's not still very clear how to even think about it in the first place.
True, right. Something that he mentioned here that
article.
Yeah, sure. Please go ahead. If they can. It's. I mean, you don't necessarily have to be like a Bitcoin developer or very much into Bitcoin. If you have an eye for basic mathematics, you'll be really enjoy it. It is all about probability. We've all studied probability in junior college or school. It is all about probability. If you choose one transaction, what's the probability of you making more money? If you leave that transaction, what's the probability of you making more money? It's all probability. Cool. We go to Cashu quickly. Cashu and other ecash system design discussion. 7 weeks ago, developer Thunder Biscuit posted to Delvik Bitcoin a description of the blind signature scheme behind the Chaumian ecash system used in Cashu, which denominates balances in Satoshis and allows sending and receiving money using Bitcoin and LN. Developers Moon Settler and ZMNSCPXJ. We have somebody who's competing with ML for the most difficult pseudonym in Bitcoin. Replied this week to talk about some of the constraints of the simple version of blind signing and how alternative protocols might be able to provide additional benefits. The discussion was entirely theoretical, but we think it could be interesting to anyone curious about ecash style systems. Anybody knows what Cashu is or have heard about Cashu?
Yes, I know on a high level that it's. I'll just give a quick brief about it. What I know. So it's a Chowmin ecash system which allows you to create a private bank. What that means is that when you have an account at that bank, the bank only knows the amount and not the identity of the depositor, and they can basically have them give Bitcoin by the depositor and give them a token which represents the same value, and that value can be shared on ecash compatible wallets around, and whoever now wants to encash it for Bitcoin again, it can go to the bank and exchange it for the ecash token. And throughout the process, the bank is only aware about the amounts and not the identity of the person who is receiving that.
Yeah,
That's
perfect.
a general, right?
That's not general. That's very specific and very perfect. Also, would you like to, or anybody else would like to take a shot at what's a blind signature scheme? Because like ecash uses blind signature scheme. That is how it differs basically from other tokenizations. We have a lot of tokenization schemes. Blind signatures is the implementation of blind signatures is how ecash differs. So broadly, for those who don't know what Cashu is, it's nothing but a form of tokenization. We've all used tokens, right? We use services daily that give us tokens, whether it's Uber, whether it's Amazon, whether it's Starbucks. So you can go to Starbucks, you can apply for their membership. They'll give you a membership card. Then you pay them in your local currency, dollars, pounds, or rupees, and then they recharge that card with Starbucks reward points. All right, they are nothing but tokens. Now you can go to any Starbucks across the country and use those tokens or those reward points to buy frappuccinos or cappuccinos or burgers or whatever you want. Uber does that as well, right? You can recharge your Uber wallet with Uber money and you can travel anywhere across the country using that Uber wallet. Amazon does it. There's this Amazon Pay. Paytm does it as Paytm money. So these are all tokens that these service providers pay. You give them a legal tender, for instance, a rupee or dollar or a pound, and they give you a token which you can redeem to avail their services. So this is very similar to the token system that we experience in the contemporary world. Now, how ecash differs is that uh, the token issuer is not aware of the identity of the person who is purchasing that token, right? So if you go to Starbucks or you go to Uber, they know your identity. They probably ask for your name, your email address, ABCD. Again, they have all information, and with that information, they can track you. What are your eating habits, where you're traveling, etc., etc. Ecash is a mechanism that uses blind signature schemes. All right. Uh, so what blind signature schemes are that basically they allow you to sign a message, they allow you to digitally sign a message without revealing what that message is. Okay, so it's like, for instance, somebody is issuing a token. Okay, you go to them, you give them bitcoins. Okay, and you take a token from them. Okay, and they sign that token so that later on when you go to redeem those tokens, they can see that they have signed it, but they cannot see the message, they cannot see who to whom they are handing over these tokens after signing them. Like what is the identity of that person? They just know that this token was signed by me. Okay, so they can redeem that token, the token issue, but they do not know the identity of the person who possesses that token. This is what blind signature is. It is wonderfully explained by Chandra Biscuit. Again, whoever has time, I would definitely urge you, encourage you to uh, go and read through this article. If this doesn't explain to you what Diffie-Hellman is, then I personally am not aware of what will ever be able to explain to you what Diffie-Hellman is. What does the Diffie-Hellman public key exchange? What is the Diffie-Hellman point? And how ecash works and how blinded signatures work, and what tweak is done to change a regular signature into a blinded signature. This is probably the easiest article that you can come across on the internet. Okay, so go through this as well.
Just the thought that I wanted to share. So I know that I remember reading that Bitcoin is a new invention, of course, but Chowmin mints is actually something that has been around for at least 4 decades, and it's interesting how it was possible all the time to create private banks as such that you do not need to know the identity of the depositor and exchanger in future. So if you have a bank with, if you deposit money with me and I give you a token, you use it around in the economy, and somebody else now comes to redeem that token, they can do that. And they have gold or whatever deposited with me. as collateral. So I do not need to know their identity. And as long as we had computers, which was there at least for the last 5 decades, we could have had private banks. It was just a conscious choice that the fiat system never considered it important to have privacy for its users.
But my understanding is at the end of the day, this mechanism is centralized. Right? There's a centralized mint. Okay, what if the mint goes corrupt? Like the primary issue with the banks is that the central bank starts printing money. It's not that the central bank doesn't return the money to you, right? If you deposit money in a bank, you go back to the bank to ask for the money, they give you the money. Okay, fine. Identification is an issue that they know who you are, they know your spending habits, which can be combated via ecash. But eventually, my understanding is that ecash is still centralized. You need a central mint, and if the central mint decides to cheat, like for instance, if a central bank decides to print more money and inflate your savings, if there is some mechanism, there is some tweak that the mint can do to bluff you or create dummy tokens or whatever, I don't know. But the point is that this is still centralized. Right? So it's not a complete substitute.
Right.
It's not complete alignment with the cypherpunk ethics, or it doesn't completely make you a sovereign individual. It's an upgrade definitely over the contemporary custodial mechanism. But at the end of the day, you do have to rely on a mint.
Yes, it does not solve the problem of centralization and trust. Yes, that's Bitcoin. That's only Bitcoin.
Right.
Faisal, how is this different from Fediment? Fediment uses Lightning. That's if I'm not wrong.
I am not honestly, I am not very well aware of Fediment, but I personally believe that there is no difference between this and Fediment. That is just my take. Okay, you can do a research. I believe Fediment is doing what Cashu is doing. They are basically minting tokens. It's a centralized entity that's from you and issues mint to you in exchange as tokens, which you use. And all the people that have the same tokens can swap those tokens among themselves, and that is what Cashu is doing. So that is my understanding. If I'm incorrect, let me know. I believe that they are doing the same.
Yes, I think you're right, because Cal also mentioned in an interview that Fediment and Cashu are both implementations of the same concept called Xiaomi and ecash.
Yeah. As Fediment goes, once you have a federation, then all other transaction takes place through Lightning. That's what I understand. But in Cashu, there is a creation of a new token. So I think that's where the difference lies.
I think Fediment also does require you to create a new token. I don't think that's the key differentiator. I think Fediment is building towards a more open source ecosystem where anybody can spin up their own mint, and Cashu is just one implementation of the same concept that Cal has built. I don't know if tokenization is the differentiating factor.
Cashu tokens, I don't think Cashu tokens are swapped over the Lightning protocol. I don't think. I mean, your first payment, like when you mint tokens, you need to use the Lightning network, right? You pay the mint in Lightning, okay, and the mint issues you tokens. Once you have the tokens, I don't think you need the Lightning network to swap those tokens. It happens over a different software protocol, if my understanding is correct. You don't need the Lightning network to just swap those tokens among yourselves.
I also think Lightning network is relevant to trustlessly using money, right? So if you're already trusting a mint to not devalue or increase the supply, why would you want to use a trustless protocol to send ping, right? Or I don't know.
You already have custodian wallets, right? You already have custodian wallets on Lightning.
Right, good point.
Or as Fediment goes, the main selling point is that you have a secure community kind of thing where you trust your federation, and then you trust them not to argue. So that's the main idea behind Fediment.
So this sounds pretty similar to Liquid. If you all have heard Liquid, right? There's an organization that buys bitcoins against liquids, and it's basically custodial, but instead of giving the custody of your Bitcoin to one specific company, like putting all the Bitcoins in Coinbase's hot wallet. What Liquid allows you is that there might be 15 different companies or 20 different companies, organizations, geographically diverse across the world. You trust them. So there's an entire organization behind Liquid of multiple companies that cumulatively a huge wallet where they keep Bitcoins. Okay, and one Bitcoin is equal to one Liquid. So even Liquid is custodial, but the benefit is that it's custodying all your Bitcoins to one entity, whether it's Coinbase or whatever, or Binance. You split your custody, you give your custody to 15, 20 people, and the majority of them will have to rug pull you for you to get rug pulled. So I'm assuming Fediment is similar to that. There is an organization of a bunch of people to whom you custody your tokens, and the majority of them have to rug pull you. And the chances of that doing is lesser than one person or one single-handedly rug pulling you.
Yeah, that's right. That's right.
All right. Yeah. Next, let's move on to the next one. Continue discussion about 64-bit arithmetic of input of in-out amount upload. We already reached the 9 o'clock mark, so I'll probably not read through this. Okay, I'll just go through the gist of it. Okay? A few weeks ago, we discussed about the proposal that wanted to allow the facilitation of arithmetic between 60, like that wanted to allow 64-bit arithmetic on the script. Currently, the opcodes in Bitcoin that form arithmetic, optimal, opsub, etc., allow 32-bit arithmetic. Okay, and the highest value of Satoshi can go up to 51 bits. So, like very, very exponentially high calculations, and the current implementation of Bitcoin code on the script is not possible. So, there is a proposal that we consider that new opcodes should be introduced, and the previous opcodes should be replicated, and the new arithmetic opcodes should allow 64-bit arithmetic. So yeah, this is a step in that direction. An opcode was proposed of in-out amount. Okay, this is the opcode that's been proposed, and what's been proposed that this opcode should be compatible with 64-bit arithmetic. What this opcode does is basically, if a group of people jointly own a UTXO, okay, let's say there is one Bitcoin which is owned by three people, Alice, Bob, and Chan. Alice owns 0.33 BTC, Bob owns 0.33 BTC, and Chan owns 0.33 BTC. All right, three of them together own that UTXO. So Alice should not be allowed to withdraw more than 0.33 BTC, and Bob should not be able to withdraw more than 0.33 BTC, and Chan should not be able to withdraw more than 0.33 BTC. So each a participant in that shared UTXO should not be allowed to withdraw more than what their share is. This is done by opt-in-out amount. Okay, so what this opcode does is that the share that you have put in that transaction is put on the stack, and the share that you are trying to withdraw from that transaction is put on the stack. And only if the amount that you are trying to withdraw from that share transaction is less than the amount that you've added in the input of that transaction will the transaction execute. So it will ensure that in a shared UTXO, if a person wants to spend some amount, then they can only spend the amount that they have input into that transaction. This is what this opcode does, opt-in-out amount. I mean, it's a proposal still, and like the developer proposes that this should be an opcode that should be compatible with 64-bit arithmetic, because this is the developer himself that proposed the 64-bit arithmetic a few weeks ago in Operator 285. Okay. Yeah. Any questions about this or any suggestion?
So is shared UTXO related to covenants, or is this just a general idea of?
No, I think this is a general idea of shared UTXO.
Is that some multi-sig where it's one of n and anybody can spend from that?
No, I mean like people can consolidate and make UTXO. And what mechanisms can you think of where people can share UTXOs? Multi-sig is one, right? Are there any other mechanism like for payment batching? Payment batching can also be a mechanism, right, where multiple people can own a UTXO.
No, payment batching, you're spending one input to multiple recipients or multiple outputs, but there's still one person or one entity or one address that's the owner of the UTXO, right?
No, that is if that payment batching is done by an exchange, then yes, but it's not necessary that you don't necessarily have to put one input. You can put three inputs and give 300 outputs. It's possible, right? Like for instance, if any exchange is disposing withdrawals to the clients in that situation, yeah, that's true. But let's say, what if the exchange doesn't have one single UTXO? Even in that situation, the exchange might use multiple UTXOs, right? Like for instance, if an exchange wants to pay one Bitcoin to Alice, one to Bob, and one to Chan, okay? And they don't have a single UTXO that is worth three BTC. So they will have to consolidate that UTXOs, right? They might have to use two UTXOs, three UTXOs, four UTXOs. So there might be a use case where two or three people come together and join their UTXOs and then pay those UTXOs to multiple people that maybe they owe. And only those people that owe those specific UTXOs can take from my share. So person A, person B, person C can come together, consolidate the UTXO, okay, and put three different inputs to make one UTXO, and that UTXO pays to 12 people. Person A owes to 4, person B owes 4, and person C owes 4. So we need to ensure that those people to whom person B owes can only take the amount that person B has put into that UTXO. Okay, this is like hypothetical, not a hypothetical situation, but this is not. You are probably looking at it specifically in context with payment batching for an exchange. The payment batching is not specific to an exchange. Anybody can do that to reduce the fee of a transaction.
Right.
And
Right. I'll try to read more about how is a shared UTXO defined, because even when people are coming together, they are coming with their own UTXOs, right, and using them as the input in the same transaction. Those are different UTXOs being used as inputs in that transaction, right? It's not a shared UTXO.
Yes, but when you put those, when you consolidate those inputs, they become a UTXO. One transaction can have 100 inputs and still be called one transaction.
Right, but it will have multiple UTXOs, right? It will be plural. And a shared UTXO, I think, my guess is that by definition, shared UTXO means that one UTXO being shared by multiple entities. Which I think multisig is by definition.
No, I mean they were 100 different UTXOs before they got consolidated, right? Once they get consolidated, they are one single UTXO.
Okay, right. I think that makes sense, right?
So there are different inputs, but those inputs all together are one single UTXO.
Right, and to spend that, it will have to be one private key, right? When you consolidate that key.
I think there are multiple mechanisms. Some exist right now, and I think some are being proposed. Okay, there's also proposal that one person will get the private key. We discussed this previously. Okay, there is a proposal that is being made that one person will have a private key, and they will have to deposit the money. Like for instance, there's one Bitcoin. It's Bob and Chan own 1/3 of the Bitcoin. Okay, and let's say they allow Alice, they give authority to Alice to spend the transaction. Alice will have to deposit 2/3 of the Bitcoin in an escrow account, quote unquote. Okay, so if Alice tries to cheat and it is proven that Alice cheats, 2/3 of the Bitcoin that Bob and Chan were deprived of will be given to Bob and Chan respectively. So there's one proposal that's being considered on this line as well. One person will get the authority, but the maximum amount that person can cheat to will have to be put in an escrow account, and that person is called cheating. That line will be lost, and like the people who got cheated will get that money. That is one mechanism, but there can be multiple mechanisms. They can, I mean, with governance, they're also discussing that each recipient can single-handedly spend his UTXO and then again consolidate. So if there are 100 recipients, one person opts out, takes his share, and then he recreates the UTXO somehow, and those 99 people have any UTXO.
Right. I think you're right. I think governance allow for trustless sharing of UTXO, but sharing of UTXO is possible by multiple mechanisms.
Right. Cool. We go through the next one. Again, I won't be able to read it. It talks about improved reproducible ASMap creation process. Okay. So basically, a Bitcoin node. Okay, I'll just briefly explain what this news article is. Bitcoin node has inbound peers and outbound peers. We're all aware of that. There are 11 outbound peers. Now, these outbound peers, like we've discussed in preceding weeks, are responsible for sharing information pertaining to the blockchain with you. They inform you about the new transactions. They inform you about new blocks. They inform you about block headers. They share compact blocks with you. You can get data information to them and get information pertaining transaction, the missing blocks, etc. Right? So they are how you get in touch with the blockchain. And even if you are in touch with one single honest outbound peer, then you get relevant information and you are immune to something which is referred to as an eclipse attack. Now, what can happen is that an attacker might occupy all 11 spaces for outbound peers. Okay, so let's say the reason why we have 11 outbound peers is that at least we should get in touch with one single honest outbound peer to get information pertaining to the node. What if somebody takes up all the 11 spots? What if that happens? What if there is an attacker and the roads that are being run by that attacker occupy all the 11 outbound peers? Then you have no avenue. Your attack, is completely surrounded. And this is what we refer to as an eclipse attack. So to make a to reduce the chances of an eclipse attack, this ASMap creation process is being considered. What is this ASMap? Okay, so this will be like a map that will map IP addresses with ISP service providers. Okay, I mean, those 11 nodes obviously will have different IP addresses. So if an attacker tries to attack you, they will attack you with 11 nodes, let's say, and those 11 nodes will have different IP addresses. Okay, and there's no way for you or your node to figure out that all those different 11 IP addresses belong to the same person because they have different IP addresses. Okay, but there's one mechanism, the ISP service provider. Okay, so if all those 11 nodes have the same ISP provider, the internet service provider, then there is a high possibility that that person can be a single entity. All right, because 11 nodes might have 11 different IP addresses, but there's a very high possibility that all the 11 nodes, because they're being run by the same person from the same geographical location, they might have the same internet service provider. So what ASMap does is that it links IP addresses with ISP addresses. So if one of your peers has a specific ISP address, your second peer will have a different ISP address, your third will have a different ISP address. If two peers have the same ISP address, the ASMap will notify you that hey, you're connected to two different outbound peers that have the same ISP address, which means there is a high possibility that they are from the same geographic location, which means that there is a high possibility that this is the same person. You would not want to give the same person access to two of your outbound peers or three or four or five or 10 or 11. All right. So it's better that you use all 11 nodes or you connect with all 11 outbound nodes that have different IP addresses. Okay. And that have different ISP addresses. So this is what ASMap is. ASMap is an entity that links IP addresses with ISP addresses. So you can see what are the ISP addresses of your outbound peers and ensure that all 11 outbound peers have different ISP addresses. That this increases the possibility of you connecting to 11 different people, thereby this can like act as a mechanism that prevents you from an eclipse attack. This is basically what ASMap is. It's something that's been worked on to the best of my knowledge. Okay, and it'll be implemented in Bitcoin. Any questions or thoughts about this?
I think it was pretty clear how you explained it.
We'll go through this changes to services in client software and release and release candidates and notable reporting documentation changes. This week it was a little lengthy, so yeah, try and wind this up in 5 to 7 minutes, not taking all of your time. Multi-party coordination NWC announced Nostr Wallet Connect is a coordination protocol to facilitate communications and interactive use cases involving multiple parties. And the initial focus of NWC is Lightning. Interactive protocols like join pools, ARP, DLCs, or multi-signature schemes could eventually benefit from the protocol. What this appears to be is like this Nostr Wallet Connect. Okay, it's a mechanism through which you can connect your Lightning wallets with the Nostr network. You can use, for instance, your Nostr private key to log into your Lightning network. You can use your Nostr public key to sign information that you share on the Lightning network generally, and share that information over the Nostr network via Nostr relays as Nostr events. So any information that you share with people over the Lightning network, you will now be able to share that information, at least some of that information, over the Nostr network using Nostr relays as Nostr events, using Nostr private keys and public keys. What this does is that it is considered that building applications on top of Lightning is very complicated, and building applications on top of Nostr is relatively easier. So if anybody wants to develop a Lightning app, they can make use of the Nostr ecosystem to build a Lightning app that does the same that a Lightning wallet would, for instance, do, but delegates a lot of work to the Nostr network and uses Nostr relays and Nostr events for the information or to share and receive information from one Lightning client to the other Lightning client. What being considered in the future that joint pools or DLCs, multi-signature schemes could also be deployed using this mechanism. So basically, you can do a lot of stuff from your Lightning wallets over the Noster ecosystem using Noster private public keys and Noster relays and events. Unity wallet version 0.5.7 release, the Unity wallet release adds page on support and makes improvements to NWC and LSP features. So the new release of Unity wallet is a page join feature. Hoping most people here know what's a page join. Page join is a mechanism in which when the sender sends a payment to the receiver, the sender also includes an input from the receiver. So if Alice is paying X bitcoins to Chan, Alice will also include an input from Chan himself. Okay, so the input, I mean, the inputs will belong to the sender, but one input will also belong to the recipient and will be sent back to the recipient. It is only a mechanism that obfuscates or creates more ambiguity for people who are trying to spy the blockchain and trying to link the sender and the receiver and who's sending the payment to whom it's sending. It's just a mechanism to make them work harder, that the receiver also puts an input and sends it to himself. So it's not very clear that who the actual sender is and who the actual receiver is. Group Hub transaction batching service. Group Hub is a batching service using PSBTs with limitations. So Group Hub, it's a batching service basically, right? We don't know what batching transactions are, and it uses PSBTs. I did not get a lot of time to dig deep into it, but the word things are pretty self-evident that it's a batching service using PSBTs. Bolts announces Taproot swaps, non-custodial swap exchange. Bolts announce upgrade to their atomic swap protocol to use Taproot swap signatures and use it. For those of you who don't know what Bolt is, it's basically a mechanism or an entity that allows you to make swaps between Bitcoin and Lightning and Liquid. So you can swap your Bitcoin for Liquid, and you can swap your Liquid for Lightning. You can swap your Lightning for Liquid and Lightning for Bitcoin. It allows you to swap between all three of these networks, all right? So you can pay them in Lightning and get it converted to Liquid.
Right, just a quick question. I don't know if it's related to this, but I know that there's something called atomic swap and there's something called submarine swap. Are you aware of the difference between the two? I've heard them a lot, but I never quite understand the difference. I know Moon uses. Right, but have you heard this term a lot? Submarine swap. I hear it sometimes.
No, I have not. In fact, I'm hearing this for the first time. Submarine swap.
Right, but atomic swap, I think, is the idea of just swapping a Bitcoin transaction for a Lightning payment, right?
Yeah, it can be a swap between two different cryptocurrencies altogether, like between Bitcoin and Litecoin. It can be an atomic swap between L1 and L2, Bitcoin and Lightning, for example. It can be a swap between Bitcoin and its sidechain, like Liquid. So, like an atomic swap can be a swap between anything.
Right.
The swap that you mentioned.
Also, two Bitcoins can be swapped atomically. Like that's a coin swap. Where you can swap one Bitcoin with another Bitcoin. Even that is an atomic.
I think
So
the
you were
swap,
saying something?
yeah, the swap that you were mentioning was probably submarine swap, wherein you exchange Bitcoin with Lightning.
Yeah, I think that's the Moon swap. So Moon is not a Lightning wallet at all, but if you notice that it allows you to receive and send payments to LN invoices. So how that does is called submarine swap, which I think is a smaller Venn diagram in atomic swap. It's my understanding. I might be wrong.
I think submarine swaps and atomic swaps are different. In that's what my hunch is. Atomic swaps essentially just means that the unit exchange will be atomically. So that like there's no chance that either it will happen. So either that Bitcoin transaction will happen and in exchange you will get Litecoin, or either it will not happen at all. Like that's what I think atomic means. And submarine to me means that it's not visible, but like the Bitcoin changes hands and in exchange Lightning sort of sats gets accumulated at the Lightning address that you own. So these two are different things.
Right.
They're
I
not-
think you might be right. I think the atomicity is defined in cryptography a lot of times. We saw that in Lightning Network as well. So I think the definition of atomicity is right. Submarine swap, I hear that especially in the context of Moon, but I don't know what it is.
So, like, nice assignment for us to go through what submarine swap is. At least for me, because I'm hearing that term first. For Lightning 24.0 RC1 is a release candidate for next major version of Optech. 24.02 RC1 is a major candidate. This version is a major candidate for the next upgrade of OLID, CLM. Notable code documentation changes. I just summarize what this is. Yeah, a new point selection strategy has been implemented for Bitcoin Core. Up till now, we had 3 branch and bound, knapsack, and random point selection. Now there were 2 more proposed. I think one has been implemented, which is coin grinder. Okay, what it does is that when the fee estimates are very high, if you use large inputs, minimize the fee, and then when the fee estimates are low, if you use 4 inputs, because that is fee environment we're using scattered inputs is better. So if you have big inputs and small inputs in your wallet, then it will look at what the fee estimates are. If the fee estimates are very high, it will use big inputs, make the fee very minimal and optimal. And when the fee estimation is low, it will take most of that situation to consolidate small UTXOs while you're making a payment. So it basically takes the fee rates into consideration while selecting the UTXOs that you want to spend. Uh, Another upgrade is dual funding. We've talked about dual funding at length. So, like the bolts 851, this is the PR adds support for dual funding to the LH specification. All right. So dual funding support has been added. I think T has to read about this as well. Dual funding. Up till now, we have like single funding where if Alice and Bob want to set up a Lightning channel, only Alice can fund that channel. Okay, but dual funding is where Alice can fund that channel, even Bob can fund that channel, Alice and Bob both can fund that channel. Okay, so it's not that 2 people necessarily have to fund the channel. Any one of the 2 can fund the channel, or they can mutually fund the channel. So this PR has been implemented. This functionality has been implemented in PR 851. And this also gives rise to what we discussed, I think, 5 or 6 weeks ago, liquidity advertisement protocol. I think this was news at 25 or 86, something like that, where you can advertise for liquidity. Okay, so if you have spare liquidity, you can advertise that, hey, I have spare liquidity and I'm willing to set up a dual funding channel. And whoever wants to set up a dual funding channel with you, you can provide liquidity to that channel, and you can pay a fee for providing that liquidity, and you can also take routing fee. This is what liquidity advertisement protocol is, and this is only possible with dual funding lightning channels. So yeah, dual funding lightning channels have been implemented, and this also opens up the door for liquidity advertisement protocol, which is being tested to the best of my knowledge. Yeah, this week was pretty long. Even took almost 100 minutes for the developers to discuss the content in their podcast, and it took us 60, 65, 70 minutes. Right. Anything to share? Closing comment? Any thoughts, questions?
This is an amazing session. I think I just have one feedback and we can discuss this, that I think news is the meat of the Optech newsletter. So we can discuss that in detail. And maybe that is something that we can discuss more, and the next sections, I don't know. So I'm just trying to understand if how to best fit it in 1 hour, because I think there's 1,000 rabbit holes in this one newsletter. So
Exactly, and I think that's what we did today, Stan, because I think 90% of the time we gave to the news. And I think 10% of the time we didn't even read
yes,
from year till end. We didn't even read.
makes sense.
That is
Yes.
what I generally try to, because even the developers talk a lot about this, and you get a lot of resources basically to research about these things. But as far as the coding documentation updates are concerned, there is not a lot of content available out there. Except if you're specifically working on that protocol, then maybe you have information that is not available to the rest of the world. But other than that, you will not find documentations or articles or blogs or anything like that where you can go in detail and figure out what these things are. Your only access to understanding like this is probably the podcast itself, because the developers who are working on these protocols, on these wallets, on these protocols, they are the ones that come to the podcast and share it. That probably is the only source of information that we have about these things. Very little. So yeah, that is what the approach has been. I think that will be the best approach.
Right. Also, I think you can share the link to the podcast in the description as well. So there's already the operator, and I think if it's possible, you can include the link to the podcast as well. So is it on YouTube?
In the
Because I've
event,
never
you're
watched-
talking about the event?
Yes, on the Discord server. Yes.
So I always do that. I think this week I forgot to do it, but other than that, I always do that.
Okay. Great. So I'll try to
make sure I do that.
and I'll try to cover the podcast as well before I join.
Yeah, sure. Okay, right. Then if nothing else, we can wind up for the session.
I think it was a real interesting session. I got to know about a lot of new things. And I think, but as a beginner, it will take some time for me to digest it. But at the end, it was really helpful session. Thank you, guys.
As a beginner or Saurabh joining, right? If you were able to understand even 10% of what we covered today, you should pat your back. As a beginner, the fact that you lasted throughout the entire session is in itself very commendable. Yeah, you need to be patient and we learn week by week. And you can go to their website, okay? This is bitcoinops.org, okay? I think Wednesday, they upload the newsletter, okay? So Thursday morning, Indian time, you'll get the newsletter. You can read through the newsletter. They have a lot of links that you can go through. And I think Thursday or Friday on their homepage itself, they upload a podcast where developers come, all right, and they discuss just like we discussed, okay. But these are like experts, the names I mentioned. They come and they discuss it, so you can listen to the podcast as well. They are on YouTube as well by the name of Bitcoin Optech. Sorry, they are on Twitter as well by the name of Bitcoin Optech. So you can follow them and you can switch on your notifications. So whenever a newsletter has been uploaded, you get a notification. Whenever a podcast has been uploaded, you get a notification. So next week onwards, when you come, you can come relatively more prepared and have a better understanding and enjoy the discussion more. And also we have
Right.
other weekly sessions. Okay, like Wednesdays, Shiryan hosts the session on economics. You can join that as well. That is like for absolute beginners. You don't need any. You don't need to be a developer or don't need to have any immediate technical understanding. We just talk about Australian economics and share our views on Wednesdays, 8 p.m. Indian Standard Time. On Tuesdays also we cover the Lightning Network. There's a book titled Mastering the Lightning Network. We read through that book on Tuesdays. That is also very beginner friendly book. So yeah, Tuesdays and Wednesdays, these two sessions as beginner would help you really if you can regularly join the Lightning session on Tuesdays and the economics sessions on Wednesdays.
Right. I'll go through it definitely. And thank you for so much guidance.
You're most welcome. We have event cards as well. Okay, in Bitshala, you can go to the event card and all the weekly recurring events are mentioned along with their time and their subjects and their hosts, etc. So whatever interests you, you can join. All right.
Yeah, sure. Thank you.
Okay. Bye. Bye. Good night.
Good job, Fazil. Thanks.